My name is Sudi Jawahari, and I am a control engineer working at Cybernetica in Trondheim, Norway. In this video, I will be presenting the digital twin technology being developed for the gas treatment center at Norsk Karmøy technology pilot as a part of the COGNITWIN project. First, I will go over the data sources that are used by the digital twin. Next, I will show how the digital twin processes the data in order to produce real-time predictions of the gas treatment center. Finally, I will discuss how the digital twin can be used to improve and automate plant operation. The gas treatment center, also known as the GTC, is the focus process of this case. The GTC is delivered by GE and has two main purposes. The first purpose is to clean the fumes produced by the aluminum electrolysis process of toxic components, primarily hydrogen fluoride, also known as HF. This ensures that the emissions from the aluminum production plant are not harmful to the environment. The second purpose is to capture and recycle as much of the fluoride lost by the electrolysis process as possible. Aluminum electrolysis requires the use of fluoride-containing species. Some of the fluoride is unavoidably lost and transported away from the process by the fumes. The GTC uses alumina to capture and clean fluoride from the fumes. Because alumina is the raw material for aluminum production, the fluoride is effectively recycled by the GTC. GTC data for the digital twin comes from three places: the fumes, the filter compartments, which are each made up of an adsorption reactor and a baghouse filter, and the silos. The primary silo stores fresh alumina shipments, while the secondary silo stores alumina that has already been processed by the GTC and is ready to be sent back to the electrolysis cells. The fluoride content of the fumes is measured by an HF laser. The flow rate of the fumes is estimated. The temperature of the fumes is measured both before and after an integrated heat exchanger, also known as an EHEX. Measurements of the alumina levels in the silo and GTC operational parameters are also recorded. The data from the GTC is passed to a Cybernetica OPC UA server, where it will be made available for the digital twin. The electrolysis cells are located in the pot room of the aluminum production plant. Because the fumes to be cleaned originate in the cells, data from the pot room is also passed to the server for use by the digital twin. Alumina is the raw material used to produce aluminum and is used by the GTC in high quantities to clean the fumes. Alumina is shipped by boat from Hydro's bauxite processing facilities in Brazil to Karmøy and other destinations. Each delivery of alumina has its own alumina certificate, which provides information about the quality of the material and its expected performance for fluoride recovery in the GTC. An example property on the alumina certificate is the LOI, which stands for loss on ignition. The LOI, shown in orange, is correlated with the fluoride emissions, shown in blue. The LOI is therefore a predictive factor for how much fluoride the electrolysis cells are expected to lose when the alumina eventually reaches the pot room. This certificate data is passed to the server to be used by the digital twin. The last piece of data used by the digital twin is the weather. The weather is critical for developing an accurate prediction of fluoride emissions. SINTEF has developed an API that can retrieve weather data from the Norwegian Meteorological Institute, also known as MET. The closest weather station to Hydro's Karmøy plant is at Haugesund Airport. The SINTEF API can be used to retrieve both recent historical weather measurements as well as the forecast, which allows the digital twin to be used to anticipate future changes in emissions. Both the measured weather data and the weather forecast are passed to the server for use by the digital twin. Here is a simulation of the digital twin in action. The top row shows weather input data while the bottom row shows digital twin outputs. Each time step on these plots corresponds to a minute. The orange curve is the digital twin prediction for MOI, which stands for moisture on ignition, and represents the weight percent of moisture adsorbed in the secondary alumina leaving the GTC. The blue data curves show the temperature and absolute humidity of ambient air. The weather shifts to cooler temperatures and lower humidities around minute 16,000. Because the available moisture in the air is lower, the moisture content in the alumina also starts to dip and eventually bottoms out around 30 hours later. The dark blue curve is the measured HF emissions level, and the overlapping lime green output curve is the corresponding digital twin prediction. In this simulation, the digital twin is running ballistically, without adaptation to the measurement. Still, the digital twin follows the long-term trends in the measurement data and predicts the average emissions values with good accuracy, with occasional exceptions. The data from the digital twin will be passed on further to data visualization and process control applications. A data visualization application will highlight the most important current and future predictions, such that operators can monitor the state of the GTC. Operators can then use the insight gained from this application to adjust GTC operation. A process control application based on Cybernetica AS will use the digital twin data to determine optimal GTC operation. The goal of the optimization will be to achieve stable and even HF content in secondary alumina, such that the fluoride recycling to the electrolysis cells is predictable. The operating variable that will be adjusted to achieve the optimization is the alumina flow through the GTC. By adjusting the residence time of the alumina in the filter compartments, the HF content can be manipulated within constraints set by minimum and maximum alumina level requirements in the GTC units. The process control application can be used to automate GTC operation, and the proposed operating changes can also be displayed by the data visualization application.